Hello and welcome everyone to C# 103 Week 3. I'm going to be here, so will Gavin.
Hello.
And Jason.
Hello. All right. So where are we at? What are we doing?
Today, everybody in this room is going to walk away understanding LINQ completely. That is my absolute most important goal for today.
Wow. Cool. So now let me ask you, when the class actually goes past midnight and into tomorrow, is it? I'm just trying to figure this out ahead of time. Is it still considered today? Or do you mean when everybody wait? Or do you mean when everybody walks away from this class session? Since the goal is to make sure they 100% everyone 100% understands it. Does that mean, if the class goes on for 4 days, it's still...
You see, LINQ isn't difficult to understand.
I know that, but neither...
It depends on your definition of the word understand, you see. We could send people away in 5 minutes. LINQ is great. It lets you write less and lets you write things in a more sensible order. There you go.
The end. Yeah, okay, fantastic. And with that, you guys should all be experts now. I look forward to seeing you do it in your homework, and we'll wrap today's class up. Let's go for drinks.
The MSDN URL, and they're done. That's how
Margaritas!
That's all the help I got.
I'm just saying.
All right, well, yeah, basically last week, when I only had like an hour to introduce LINQ, there were a lot of people, I think, that weren't quite getting it. And for 103, this is the most important concept. And it's not just necessarily LINQ, it's also the things that create LINQ. It's also iterator blocks, IEnumerables, generics, delegates, lambdas. So when I say understand LINQ, it's how does it work? What features does it use? How can you use LINQ in your program? And how can you use the features that LINQ uses to be awesome to create your own awesome code?
Awesome.
All right, so let's go ahead and fire up. Okay, so at the core of LINQ, it's all about IEnumerable. We've been talking about IEnumerable a lot, and we had a lot of confusion last week about IEnumerable. So people were asking stuff like, how can you add an item to an IEnumerable? Remember, IEnumerable is all it is. If I were to go ahead and write an implementation of IEnumerable right now, it would look something like this.
I always feel chase music is required when Nelson's typing.
These are the core members, the most important members of these two interfaces that are tightly connected. We have IEnumerables and IEnumerators. And an IEnumerator represents a pointer, or not a pointer, but a current, it represents two things, the current item we're looking at and a mechanism for moving to the next item. And that's all it is. And what we have are things like lists. So in this case, this list implements the IEnumerable. IEnumerable itself does not expose any mechanism for adding any item to a collection. The way in which it collects data is dependent on the specific IEnumerable. So for example, in this case we have a list, but we could just as easily have a even number generator that implements IEnumerable of type int, for example. It doesn't really make sense to add things to an even number generator because it's not really a collection. It's just a sequence. So you really have to, the first thing that I want people to understand is at the core of LINQ, at the core of using collections properly, using sequences properly. IEnumerator is a sequence. You don't add stuff to that sequence. You mutate the data from the sequence and create chains of operations. So like in the previous example, we might have, or an example that we had from last week, we might have have this. And one of the biggest confusions that one of the things that people were confused about is how these different sequences relate to each other. In this case, we have just a collection. It's just a collection of 6 numbers. That's all it is. In this case, we have what's basically in object form. So obviously this is using object-oriented principles, but in object form we have an operation that we performed on the collection. So there's no way to go from this filtered object back into a list. That's impossible, and there's no need to. So for example, let me go ahead and take away the implicit typing. You'll notice that the types are very important. And the object that's actually returned by where and select are the result of the compiler generating the code iterator blocks, basically. When you create an iterator block, compiler generates a class for you. When you invoke a method that is an iterator block, you get an instantiation of that type. But the backing type of these two local variables is completely irrelevant. We don't really care what the real type of them are. We just care that we can access them via the IEnumerable interface. So in this case, what we have is our operations, meaning if I go ahead and say for each var item in squared, console right line item, and then I mutate the original collection by clearing it out, or how about by adding in 10, and then I perform that same operation again, run this.
What will be the output?
Actually, well, if people want to take a guess. Yeah, that shouldn't be that hard to figure out, actually. So what's the output to this program? And the room goes silent.
I can't handle the anticipation.
Gavin?
Hello?
I'm scared. Hold me.
Oh, now I'm scared.
Now you're excited. What are you talking about?
Now, don't lead me down that road. That's
Yes, clear your throat.
coffee.
All right, so if I go ahead and hit F5, we'll see this. What this is an example of is it's called deferred execution. And remember how I've been saying that these objects, while they are objects that implement a particular interface, filtered and squared are both objects, what they represent is an operation on some other bit of data. And when the other bit of data changes, so does the result of our operation. Now, that's in LINQ, one of the first new things I want to introduce people to, I don't think I spent very much time on last week, is the ToList extension method. .ToList. What this will do is it will effectively flatten your operations. It'll compute them all and then place it into a list and return it. Now I can still reference this list as an IEnumerable of int, of course, because, well, a list is an IEnumerable of int. Alternatively, I could turn squared now into a list if I wanted to. But what this effectively does is creates a new flattened data set that represents the operations performed at that one particular time. So now when I hit F5, notice how the result, regardless of what I do to the source, the result is the exact same. So the ToList extension method is very important to flatten out operations, particularly operations that require a lot of computation. And you'll see ToList being used quite frequently, especially to avoid situations where changing data in one part of the program can affect the results of other parts of the program. Now, it is very typical that you don't really want to mutate the source of an operation unless that's what you're explicitly trying to do, if that makes sense. You should really think about collections in a more functional sense where things are immutable. And what we're doing right here, for example, without the .ToList, is we do have a representation of an immutable concept, where we're just adding things on, we're tacking things onto a chain, and then that chain is ultimately operating under this original data set. So those are the
So adding the ToList in there works a bit like sort of adding a full stop. It makes the, when you say flatten the operation, it's quite a nebulous term.
Right. What it does is it enumerates the entire collection through well, not necessarily through a for each loop, but however it does that, and then it adds all the results to a list and returns it as a collection, not as anything else, not as an operation. It's no longer an operation; it's the result of the operation inside of a list, inside of a collection. So, how did everybody feel about the homework? Did anybody struggle with the homework, and what was people's issue if they did? Because some of these operations will only really make sense when you understand the source, and the source to LINQ is very straightforward. For example, the
I think, interestingly, quite a lot of most people's problems seem to be down to the fact that you missed the word "this" out of all the...
Well, that should have been implied, but...
No, it only happened because I remember this distinctly, you weren't initially going to write out the full signatures of everything when you were describing the homework, and then you went back and went, oh, I might as well, and just missed the "this" is out.
No.
But that was quite an entertaining discussion in the end, because we had people going, but how can we change this into an extension method? Should we be doing it like this? And then other people going, I don't understand the question. So do you just want to précis over the whole extension method idea again?
Yeah, well, an extension method, okay, so to make an extension method, you have to add a static method to a static class, and the first parameter must have the this modifier in the first bit of that method. And what that does is it makes this method, in this case my_where, added to the IEnumerable of T interface, which is actually carries some interesting implications. Typically you think of interfaces as not having logic, but what we've essentially done here is we've added some capabilities, some concrete capabilities to the interface through extension methods. So it's a very interesting concept. Quick question, since it asks separate files, I added a new class file in the same namespace as program. Program could not, for some reason, not see it. I would have to look at the code for that case. There's a variety of reasons why that might be the case. Either the accessibility of your method, or the namespace,
the class was static, but the methods are public static.
Right.
Did you make the class public?
It should, if you didn't annotate the class with anything, it should default to internal, and program should still see it. So I don't know. Alright, I got the homework done, but I did need help on how to get just one item, as in for the my first, without going through a for each loop. The homework seemed really hard at first until I looked over my screenshots, saw you did stuff last week's class, then it became clear, other than my first. Well, for my first,
The key thing there is that you break when you do find it.
cannot be an iterator block because T is not... Oh, right, of course. I can't yield return it. Derp. What am I doing? There we go.
That makes more sense. And actually, I was just thinking, given that it was due at the start of class, and like you say, this is key to understanding everything as we go forward, you might as well code out each of the examples that were in the homework thread.
Okay. Well, yeah, and I did also want to talk about some new things that you can do in LINQ, a little bit more advanced things as well today. Here, the name mywhere does not exist in the current context. Could you gist your 2 files? Alrighty, so yeah, and then as far as the other my first, we could do something like that. This.
What else do we have? MySelect.
Yep, and MySelect is going to be very similar to, I believe I already did it in class last week, but it would look something like so.
Actually, having now got to the thread, MySelect wasn't in there, but myAny and myAll are.
Yeah, so in that case, the myAny, remember any will return a Boolean. If there's anything in here. So we can just say for each var item in that, return true, otherwise return false. And then for the predicated any, it'll look a lot like our where, but instead of yielding the item, we'll simply return true if the predicate matches any. So there really is a really nice simplicity to a lot of these methods. They're very, very simple, and they're also very powerful when combined with each other.
And of course, the great joy of LINQ is that, well, you don't have to write these out. But this is the thing. By actually working out how to write them out, it comes back to what we said back in 101 with the early lessons on while loops. Okay, you don't need to use while loops if you're doing a for each. Use a for each loop. But by actually working out how to do it with limited resources, it really forces you to get inside and understand what is going on under the hood.
Exactly. Are the LINQ methods exactly like this? Yes, they're very, very similar to this. They're not exactly like this, however. The difference with the actual LINQ methods is that the actual methods you invoke are not iterator blocks. So for example, if I wanted to implement select as it's really implemented with LINQ, it would look something like this. There would be 2 methods with the same signature, but the other one would simply be private. The iterator block one would be private, and this would be called, myInnerSelect. The non-iterator block method would do validation on the parameters. It would say if that equals null or projection equals null, throw new, argument null exception or whatever. Otherwise, return my inner select that projection. So can anybody guess as to why it's actually implemented like this in LINQ?
And actually, I quite like that.
Well, there's a very, very important reason why that has to be done like this. Nope, it's not a matter of debug release or order of operation. What it's a matter of, remember that iterator blocks, when I say iterator block, I'm meaning a method with a yield statement in it. Or, well, one-to-many yield statements within it. Remember that iterator blocks are transformed into classes. Well, typically one class, actually, a class that implements both IEnumerable and IEnumerator. The C# compiler transforms this method basically into a class and then turns the method. It says all the method's body does for an iterator block is returns a new instantiation of that class. Meaning that all of the code you placed inside of the iterator block gets chopped up and placed into the move next method of the enumerable, or the enumerator. Which means that if you put any validation code inside of your iterator block, it's not going to be executed until it's put in a for each loop.
So is the TLDR essentially it would cause horrible, hard to find explosions in your code at random points?
Right. And it'll cause problems where you didn't expect them to expect the code to be a problem, because it'll only throw when you do a for each loop. You typically don't expect a for each loop to go ahead and throw a exception for whatever reason. So it's very, very, very difficult to track bugs that would be caused if they didn't do it like this.
Stephen's question that just came in kind of is something that I've been reflecting on. Are you planning on covering sort of setting up tests during this course?
I don't think we're going to be getting into unit tests this course.
Okay. And then he asked, could you show one example of using the MySelect method? I had trouble getting the syntax correct.
Right. Well, make sure that the MySelect method has the this modifier on the IEnumerable of t. This will ensure that this is an extension method for IEnumerable of t. And then also notice that it's also a public static method and it's on a static class. These are all requirements for extension methods. Now, every time we open up any enumerable, we will see that method. So for example, instead of doing filter.select, I can do filter.myselect. Instead of doing numbers.where, I can use numbers.mywhere. Notice how all of my methods appear right now in IEnumerables. And it also appears in any class that implements IEnumerable, including list and dictionary and all those. So now I have my all, my any, my first, my select, and my where. And now if I were to run this program, we'll obviously get the exact same result because my methods are correct. So does that make sense? Remember, this is an extension method. If I hover over it, there's the parenthesized word extension right there. This means that this method wasn't originally on this type, but I've made it on this type. Also keep in mind that extension methods work with scope of namespaces, meaning that these extension methods appear on IEnumerables in this file because these extension methods that are defined up here in this static class are in the same namespace as program. If they were in different namespaces, you would need to add a using statement to import whatever namespace MyLINQ came from. Also keep in mind that that's an additional requirement for LINQ. So this using system.link here is actually very important because if I remove it and open up the IntelliSense, notice how all of the LINQ methods just disappeared. Except for mine, of course.
Very nice.
I forgot. Why is it calling the method every time the loop goes through? Because what's happening is that the iterator blocks get turned into a state. That's not an iterator block. What am I thinking? The iterator blocks get turned into a state machine. meaning that what the iterator block allows you to do is whenever an iterator block hits the yield return, that keyword isn't an arbitrary keyword name. That's the English definition of what it's doing. It's yielding an item back to the for each loop and discontinuing his own execution until the for each loop asks him for another item. So then when the for each loop comes back and asks the iterator block for another item, execution will continue immediately after the yield return, which of course will be the top of this for each loop.
I have a question. Is there ever situations where you use yield without either return or break?
How do you mean? Oh, no.
No. Cool.
Yield return and yield break are the only two valid uses for that keyword.
Thank you. Did you see Wolf Knightley's question about the first?
Which was it?
It's still there.
Well, which one?
The one I haven't flagged.
I did get enumerator .current. Well, if you did this, well, not that one. If you did this, well, first of all, that the issue with that is the current isn't defined until you invoke the move next method. So if you wanted to not use a for each loop, you'd have to do something like this. That would be an implementation of my first without the for each loop. Actually, a more appropriate implementation would, of course, be that. Because enumerators are disposable. I do want to point out that, though, typically, I've never seen an enumerator that has an implemented dispose method. However, because enumerators are compatible with COM interoperability, COM iterators do have the concept of deterministically being disposed of. There's also a reset method on enumerators. So, for example, enumerable .reset, and this really should be enumerator.reset. This method almost never does anything. In fact, I believe that if you invoke this method on an iterator block, you'll get into not implemented exception. That, again, is the only reason that method exists is for interoperability with COM. And when you create a enumerable and enumerator via an iterator block, it's actually physically impossible for you to provide an implementation for reset or dispose. Those methods are always going to be filled in for you.
There was one more, my first question that came in right at the bottom of the list.
You mean Alex?
Yeah.
Well, we did get a question that I will answer. Asks, is this an appropriate implementation? Can anybody guess why this is not an appropriate implementation? This will be besides null checking, other than null checking. I'm not doing any null checking right now, so that's not the problem. There's an even more fundamental reason why this is not how you should do it. It's a very fundamental reason that's very fundamental to understanding LINQ. Yeah, people are saying because it might not be a list. What if you wanted to get the first item out of a dictionary? Or what if you wanted to get the first item out of a invocation of MySelect? Remember, the IEnumerable that MySelect returns, even if the IEnumerable that's passed into the first parameter is a list, the one that it returns is not a list. In fact, it's not a collection of any type. It's an iterator block. So what we have here is an instance where we're sort of violating the philosophy of LINQ by making this only work with one thing. And although it might seem like it works if you just test it with lists, it will throw an invalid cast exception for anything that isn't a list. So every single implementation of a LINQ method should always be written in terms of IEnumerables. And remember, IEnumerables only let you get enumerators, and enumerators only let you advance your the pointer forward and get the current item. There is one exception to this, actually. Well, it's not much of it. It's not really an exception, but it's a good point to bring up. Did I have people implement count?
No.
Oh, it's a disgrace.
Well, you could get them to do it now.
All right.
Give them the signature, and then pause the video. That'll also then you can have a look at what Jonathan gisted you.
All right, go ahead and implement these two methods. What I've been discussing actually leads directly into this, and this is another great thing about LINQ that you have to keep in mind at all times. I can't stress how important these two methods are. So I'm going to go ahead and pause the video, and let's see people implement them. And people, go ahead and hit participate if you want to. And we're back. So it looks like everybody here went ahead and got an implementation of these two methods going. I'm going to put up the implementation I think everybody probably came up with, and then we're going to talk a little bit about the implications of this method, because this method carries a lot of weight with it, and it's a method that you have to keep a very close eye on using, and the reasons for that should become fairly evident.
I'm going to type out what I think you all wrote, and then I'm going to tell you why it's wrong.
I mean, in essence, that's what he said.
That's what, yeah, to be honest, I thought he was going to say that. It sounded like it.
Okay, so is this pretty close to everybody's implementation?
Yep.
And Segfault, I know what the difference between this and what you have is already. Okay, so counting it with LINQ, the count method carries with it the implication of not only an entire enumeration of the IEnumerable. Actually, no, that's about the only implication it carries. It is required to enumerate the entire IEnumerable. So what that means is that any operation that's been attached to this IEnumerable that you're counting on will get executed. It's also not a very efficient method, and there's no way around it. There's just no physical. There's just no mechanism that you can express this logic in any way but this. This is the only answer. Now, I will show a optimization that is present in Microsoft's implementation of LINQ. It's not necessarily a requirement, but it is implemented in the Microsoft specification. But at the end of the day, if all you have is an IEnumerable, the only way to count it is to list the entire IEnumerable. So it becomes very unperformant very quickly. And as Segfault just pointed out, if you did a count on a infinite sequence, such as a sequence with all the even numbers or a Fibonacci sequence, that will never end, ever. And if you think about it, it makes sense. What is the count of an infinite sequence? Well, it's infinity. Okay, so let's go ahead and look at a possible optimization. This optimization brings about a few interesting points, and is actually what it's going to feel similar to what a person previously asked about the first method, and it is a optimization that is provided by .NET. So can everybody should already be able to understand why this is more performant, what this optimization does, what cases it'll be triggered for.
Yeah, what Paul's geeky said.
What?
Cheating. What Paul cheat? You just wanted to make me say that again, didn't you? Paul cheat. He told me how to say it. This is the thing. I asked him last week. I can't remember what he said. Paul Siski or something. Paul Cheeky. That's it. Paul Cheeky.
Yeah. This is basically a cheat. Now, I know that people already should be starting to understand the relationship between runtime types and compiler time types and types of variables versus types of objects. But if you have any problem with this code, how it works, why it works, if you do not understand the circumstances that it'll be tripped up on, please post now, because this is very, very important. I mean, we've been building on so many new concepts and concepts that were gone over in 102, and now we're actually seeing them being used in a very abstract way. See, LINQ is a very abstract framework. It doesn't do anything really specific. There are a few things like sum and min and max and other things like that that work on specific primitive types, but it typically doesn't do anything specific. Like, for example, if you look at my_where, this is a very, very abstract method. Very abstract method. And we're using the facilities of interface implementation, iterator blocks, and generics all at once to make something that will basically allow you to write code much cleaner. Okay, so what this code does, I'm not sure if I get why is it better. Is it better because it doesn't make an object? Well, first of all, myCount is not an iterator block. Can anyone tell me why myCount is not an iterator block? Exactly. Because this is not an iterator block, there is no additional object that the C# compiler generates. This is just a normal method. A normal method that takes in an IEnumerable of t and returns a single result. It doesn't return a collection of results. So myCount is important because what we have here is an example of polymorphism. We're going to ask the IEnumerable if it is an iCollection. Now, this is not a upcast, this is a downcast, meaning that we're looking for a situation that might not always work. Now, it's always true that you can go from a list of t to an IEnumerable of t. That's in the rules because list of t implements IEnumerable of t. But it's not necessarily a rule that anything that implements IEnumerable of t implements iCollection of t. So that's why we have a condition here. We're not doing a hard cast. We're not doing a C-style cast, which, remember, that C-style casts, such as this type of cast, will throw an exception if that, and when I say that, I mean that right there, is not of this type or cannot be converted to this type. This, however, allows us an opportunity to detect if it is of this type. And if it is an iCollection of t, then return its count property. Now that's a very important optimization because lists, for example, return or implement iCollection of t. All right, I have a question for everybody. Let me go ahead and set something up, and I'm going to ask you guys what the output of this program is going to be. You guys ready?
Hey, Nelson, I'll be right back. I've got a situation I have to handle.
Alrighty. Actually, I'm going to go ahead and move this method down to the bottom so we can see it. I didn't mean to go that far. Everybody but segfault, what is the output to this program? The only bits that we are looking at right now are this method right here, and then this code right here. Remember, our projection is being written in terms of this previous list. So remember, we have a list, we're instantiating it, a list of ints with 7 numbers in it. We're getting the count of the list. Then we're doing an operation on the list. We're creating a projection of a square. And then we're doing projection.myCount. All right, so I'm going to go ahead and run this. And this is what we get. We get fast way and then slow way. Here's why. If I jump into the my count right here, and Wolf, pay attention to this. I noticed you asked a question as to why this is faster or better, and I'm about to step through what goes on, so just pay attention because this should answer that question. Okay, so the execution is paused on line 110, and if I hit F11, I jump into my count. Now remember, the thing passed into my count is this list. So if I expand on that, I get a list. This is a list. In fact, I can prove it's a list by opening up my immediate window and doing that.getType. That.getType.fullName. Name. There we go. Because I'm doing that.getType.name, it's returning a list. Now remember, lists implement IEcollection. Almost every type, every collection type in the .NET framework implements IEcollection. So now when I run this code, notice how this code path gets executed because it was able to take that and turn it into a collection. So now we're looking at a statically typed collection. Keep in mind the difference between static types and runtime types. The runtime type of that has never changed. That is a list, and it will always be a list in the context of this method invocation. However, we can look at that through the eyes of two different ways. We can look at that as an IEnumerable, which constrains the operations we can invoke on it to just get a numerator, or we can look at that like an IEcollection, which we do right here. So this collection variable is typed to IEcollection, even though it's pointing to the same object. However, because we've proved that collection, that is an IEcollection, we've made that proof, we know that we can now invoke properties on the collection that are not necessarily available on every single IEnumerable. And so what we can do right now is we can return Collection.Count. And the great thing about Collection.Count is that this is typically going to be implemented in a very fast way. Generally, collections keep track of how many items are in the collection. So a list keeps track of how many items are there in the list. A linked list keeps track of how many items that are in the list. So to ask a collection to give us the count, we get a very fast bit of execution because it simply has to return a variable to us. And that's it. So by saying return Collection.Count, we're just saying list, give me the count that you have, that you keep track of. Just return me a variable. Very straightforward. That results in linear execution time, O1. And it's O1 because there's no matter how large the collection is, it will always return, or it will always perform in the same manner. It's going to perform in constant complexity. So when we return Collection.Count, that's very fast. But now watch this. I'm going to do list.mySelect. And of course, remember how I broke out MySelect into the non-iterator block and the iterator block. That's why we get this right here. But when we say return MyInterselect, we jump down. So now when I jump into my count, look at this. If I do that.getType.name, look at the type name right there. Does everybody see that? Does everybody remember what the term for a type name like that is?
Gerald?
No, there's a term that everybody always laughs at whenever I say it, but it's actually in the specification. We get unnamed, unmentionable. One person got it. Yes, this is an unspeakable type name. We know it's unspeakable because it has these symbols in it. These symbols, it's not possible in C# for us to use these symbols for a type name, although it is possible in IL. So when the C# compiler generates a type for us, it makes it unspeakable so that we can't accidentally refer to it. So yeah, so this is not a list. Although this composes a list, it's not a list. So now when I go ahead and do this collection thing, collection is null because it can't convert that into an IEcollection because that doesn't implement an IEcollection. That is just an IEnumerable, plain and simple. So now we enter the slow way, which the slow way, this is very important. Not only does it loop through every single item in the enumerable, but there's also another, there's an obvious implication to that, an obvious corollary, that because it loops through everything in the IEnumerable, every operation that we have is performed. So notice how every time count is incremented, we jump into my inner select, then we jump all the way into the projection, then we jump out of my inner blah, 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 and do that, and do that, and do that. And obviously, this is not very performant. I mean, it's occasionally necessary, and the times that you do count, honestly, are typically you're not going to notice any performance differences. But this isn't something you want to do in a game loop. And especially not something you want to do to an infinite sequence because, well, that'll crash. Well, not crash your program, it'll just sit there and spin forever.
Big reason for using collections rather than, say, just an array. In fact, it ties right back to the beginning of 101 where you were talking about arrays and having to pass around the count of them.
Yeah. Or are you thinking of C++, actually?
Probably. I'm getting... I'm losing track altogether.
But it does, yeah, and passing around...
We did something similar in C#, I'm sure we did.
Well, yeah, one of the things actually from that discussion that's important to bring up right now is when I wrote a class like this, so when I wrote a class like this, and that brings up a previous discussion, now that we have a little bit more context with LINQ, and there's a lot more to LINQ, we are going to be talking about a lot more of the operators today that are very important to keep in mind. But for now, I hope people start to realize that this really isn't that limiting. You look at this, and everybody sat there and asked me, well, why aren't you publicly exposing the products as a list? And my answer was because you can add things to the products. You can do inventory.products.clear, and that breaks the encapsulation of this data. So instead we expose IEnumerables. And although the object is the exact same, the only method that we have on this object is getEnumerator. And I could understand why people could previously think how limiting that is, but it's really not. With LINQ, we can do a whole lot of operations to this IEnumerable. All right, so how's everyone feeling? Yes, one could cast it back to a list. I actually hear that a lot, where people are like, "You shouldn't do this. You should do this." Does anybody see the difference between those two things? notice how I added a products.ToList to it. What this will do is return a copy of it so that we can't do this. See, this is valid code. If I didn't have this ToList right here, this still allows people to do everything that I said they shouldn't be able to. I could now reach into this data member and do anything I want to it. And but the important thing is it's obviously not supposed to be used like this. It's very clearly an IEnumerable product. You should never cast it to a list of products. And so some people are saying, well, to prevent people from doing that, we should do .ToList. I think that practice is silly. And the reason is, if people want to mess with your code, they will mess with your code. For example,
No, you spelled field.
no, whatever. Okay, so if people want to screw with your code, they will, because there's nothing that can stop you from doing this. I'm using reflection to reach in and grab this directly, and I'm setting it to null. So that's why I don't agree with the .ToList practice when exposing lists as IEnumerables.
Okay. Let's
I know this is a bit off topic, but I just
drag
wanted
you
to-
back to the because we're on the very verge of getting a bit esoteric, but just the wrong side of that verge. Yeah, what's next on the list?
Okay, so we're going to go ahead and talk about a few different LINQ operators that we haven't discussed before. So we should already have a good idea of select or projections or mappings, wheres or filterings, first, all, and any. So hopefully everybody did do all of that and are already intimately familiar with these different types. Or these different methods. There are a few more LINQ methods that are incredibly important. One of my favorite is the aggregate function. And I know that a certain person here doesn't really like aggregate.
I do. I mean, it's one of the more obscurely formatted things.
Yeah, it does take a little bit to get used to, but I really want people to understand it very well. And so we're going to actually go ahead and implement it. So why would you need an aggregate function? Well, an aggregate function, for those of you who were present for the F# workshops, the aggregate function is equivalent to the fold. In functional programming terms, fold is the terminology for what we're doing. And here's why. A fold, let's say we have 7 numbers. And we want to turn these 7 numbers into one number. So what do? We fold the collection in on itself. So we take 1 and we fold that into a result. We pipe it into 2 and we fold that into a result. We pipe it into 3, then into 4, then into 5, then into 6, then into 7, and then that turns into X.
28, presumably.
Well, depending on what the fold function is. Because every time you see this arrow, that's a function. And I'm saying the word function in the context of a functional function. And that function, every one of those arrows is a function that takes in one item and the result from the previous invocation of that fold. So, for example, if we wanted to go ahead and we wanted to go ahead and sum everything up. Now, I know that there is a LINQ function called sum, and we'll look it up later. But let's say we wanted to sum items in a collection. Okay, so here's our list, and we want to sum it. The first implementation of a sum that a person might do is this. I hope this code needs no explaining. So that's something that a person would typically do. But what we have here is, if you look at it closely, this code follows the pattern of folding or aggregating. We have a seed of 0. Then we loop through every item. And then we use the result of the last loop iteration in addition to our function. In this case, it's the addition operator. And then we use the item that we're currently looking at. And that's all an aggregate or a fold is. So instead of doing this, I can do this. What am I doing? Now here's the one thing. I do always get, oh yeah, never mind. There we go. The one thing that I always get tripped up on is what comes first in the function, the accumulator or the current item, and the accumulator does come first. And you could figure that out by looking at this signature, where this is a function that takes an accumulate, an item, and then returns an accumulate.
I'm glad you slipped up on that. Or at least had to think about it, because it's like I was saying, it's not doing anything necessarily any more complicated than any of the others. It's just I've always found it to be a slight blank.
Yeah, it's hard to get your mind around. It really is. I mean, it took me a while to fully understand it myself, and actually to use it instead of having ReSharper tell me you should use aggregate here, but to actually use it as the first result, first measure.
Yeah. Paul brings up a good point that I hadn't thought of. Can you just explain what a seed is?
Well, yeah, a seed is a seed. It's a value that is used for seeding an operation.
It's the start value.
It's a start.
Most commonly, you'll come across it, or you will have come across it when using random numbers. If you want to, because obviously randoms are pseudo-random, not actually random, you can specify a seed and always have it start in the same place.
Yep. Okay, so what's this function doing? This function is basically the functional form of this imperative code. In fact, this function is completely immutable. This is a pure function right here. And not only that, we are not doing any mutations. The way that this is implemented is going to look a little bit scary, but it'll at least allow us to step through the process.
Are you going to get them to do this, or are you just going to go straight into it?
I'm just going to go straight into it.
Okay.
Well, I mean, it might be. Who's up to reverse engineering aggregate? Who understands it enough? Because I think there's people who don't even understand it at all. I mean, it would be fun to do. It's a fun little exercise. But I'm going to go ahead and just implement it. Is that coming from you?
It's not coming from me. Is that Gavin's away from the computer music?
That's just what I always think of when when Nelson's typing.
Oh. I thought you just went away.
The typewriter.
I thought you just went away from the computer, and that's like your away music.
Away music. Fantastic.
It's kind of what it made me think of.
Actually, over here it's been used for the past umpteen years as the theme tune to a radio panel show. So most people from this country would think of it as being the tune to the news quiz. But Leroy Anderson, he's the same guy who wrote Sleigh Ride, actually. He's filled the world with cheesy music over the years. And say what you don't win because you doubled back without using fairlop.
Okay, so
and because that's not the news quiz.
So here's an implementation of aggregate. Keep in mind that I'm not doing any parameter validation. Aggregate is supposed to do things like throw an exception if the source sequence was empty, stuff like that. I'm not doing any of that here. Now, one of the most important things for understanding code in general, especially generic code that makes heavy use of delegates, is to look very closely at the generic parameters. So we'll notice here that my aggregate takes in two generic parameters, TACC and TSource. It returns a TACC. It takes an IEnumerable of TSource. So we already know that it's going to most likely loop over the source collection, and that the process of this method will take in that data and return a single value. That's a very important distinction, because this returns a single value, not a IEnumerable of anything. And the type...
Yeah.
You what?
Sorry. I didn't mean to put that out just then. Line 133, you've got an error. It should be sum 3.
Oh, something like that. Okay. So what we have here is, again, so if you look at the generic type parameters, you should have a general idea about what it's going to do, because we can infer, again, just by looking at the signature, we know that it takes in an IEnumerable of something, and it returns a single value of something else. So we already have a good idea about what it can take in and what it can return. And then if you look at the other method, or the other parameters, this one isn't as important. But if you look at this fold parameter is very important. It's a delegate that takes in an ACC and a source and returns an ACC. So if you think about it, you should be able to sort of get a feeling that what the function that you pass into this function does is going to take in an item out of this source collection, and it's going to take in some sort of ACC. We can maybe even infer from the signature that it will take in maybe something related to the seed, and it will return a new ACC. So what this function does is it's really just, look how similar this and this code is. Aggregate is really the abstraction of this type of operation. This type of operation where you loop over things in a collection and you return a single result out of it. Aggregates can be used to calculate sums and mins and maxes and counts even. You can use aggregate to implement count if you wanted to. Aggregate can be used to do a lot of fun stuff. And if we...
And well, case 73 said something interesting, which is, I get it, but won't remember it, lol. Which, okay, lol, but it's kind of to miss the point of what Nelson was saying. The whole point is is not what you're looking at specifically now about aggregate even. It's about, you just look at the signature, the return type, and the parameters or the arguments. I'm completely confused on which is which now, but I call them parameters that go into it. And he was literally piecing together the information that is there. It's not a question of remembering every single, signature of every single method. It's not that sort of process. It's a question of learning a way to read the signatures and return types.
Yeah, a lot of people they glaze over when they see generic types, because they're afraid that's going to be too complex for them to understand. But really, if you just, the important thing about, if all you have to remember about generic parameters, their name is irrelevant. You just have to remember, for every generic parameter that comes into a method could be a separate type. And so that's why for example, if you look at MySelect, if we do the same process, we know that just by looking at the signature, we know that MySelect takes in two types, TSource and TResult. It returns an IEnumerable of TResult, and it takes in an IEnumerable of TSource, and it has a function that maps between TSource and TResult. I mean, even if the name of this method was completely just gibberish, if you looked at that and you thought, okay, how could this bit of information come together? Why does this method need this parameter? Why does this method need a generic argument? You'll be able to sort of get a feeling for how it works or what it does. So generic type parameters are not that scary. The syntax looks a little terrifying because of all the angle brackets and the big T prefix, but it's really not that terrifying. Okay, so jumping back down to aggregate, I'm going to go ahead and, actually, you know what? First of all, I'm going to go ahead and step through this code right here. So now I'm here, the program is paused on line 125. Now, I know that everybody here will be able to do this even in their minds, and I'm not, if anybody picks anything up for what I'm about to show you, then you probably shouldn't be here. But I just wanted to go over it sort of meticulously so you can see the parallels between this and the aggregate. So you'll notice that we loop through every item in the list, and for every item in the list, we simply append, or not append, but whatever that function.
In this case, add.
Well, yeah, it's addition and assignment at the same time. Item to sum. And that's all we do. We just loop and loop and loop and loop and loop. Think about this. Think about it like this. The sum of the previous iteration is passed to the sum that we're currently looking at. Now, I know that's not actually the case. We're simply reusing the same local variable and mutating it. But think about it in a more functional way. Every single one of these, you might say for a second, well, obviously, every single one of these iterations depends on the previous iteration, because how would you get the sum? Well, that's true to an extent, but if you abstract the parameters, you'll realize that if you think of this for each loop, every iteration of this for each loop as an invocation of a function. So think about every time this for each loop runs, it is an invocation of a function. Basically, what's happening is we're getting an item out of the list. We get access to 2 bits of information. The previous result of the previous iteration, which in this case is sum, and the current item we're looking at. And then by adding this to this, what we're doing is we're essentially allowing the next iteration to see our result. We're threading sum through an invocation of a bunch of functions. Okay, so now I'm going to jump into list my aggregate. So when I hit F11, you'll notice we start very similarly. We say var value equals seed. Now, of course, that was abstracted into a parameter, but we do the same thing on line 125. We say var sum equals 0. Right here we're saying var value equals seed, and, well, seed in this case equals 0, so it's doing the exact same thing. But this is the important bit. Remember how I said think of every iteration of the for each loop as a function invocation? Well, here's what that function invocation actually looks like. What we're saying is, for every item in the list, invoke the function that we pass into it, the function that I called fold, which is of type func tac tsource tac, and pass in the old value, the value that was previously computed by the previous iteration, and the current item in the collection we're looking at, and set it to the value that we have for future use. So when I hit F11, notice how we jump into the lambda here on line 132. And if I look at the parameters, A is 0 and I is 1. That's important. A is 0 because this is the first iteration and 0 is passed in as the seed. And I is 1 because that's the first item in the collection. But if I go ahead and run this through again and look at the parameters now that we're in the second iteration of this, notice how A is now 1. A is 1 because that was the return of the previous invocation of this function. 0 plus 1 is, in fact, 1. So that gets stored in A. And then I is 2. Now, if I go ahead and loop through this again, what's the value of A and what's the value of I? Oh, I just noticed that it actually is AI, isn't it? Okay, so if I go ahead and look at A is 3, I is 3. That's because the result of the previous operation returned 3, which gets put into A, and then the current item we're looking at in the list is 3, because we're, well, on the third item. And what we return is A plus I. So 3 plus 3, we return 6. That means the second iteration of this, A will be 6 and I will be 4. And this will return 10. So now the fifth iteration, A is going to be 15, or sorry, A is going to be 10 and I is going to be 5. And then so on and so on and so on. All right, how's everyone feeling about aggregate?
I think we've probably beaten it into the ground.
Well, yeah, it's something that people trip up on so much, but it can be used for some really fun stuff. And it's good to keep in mind, if you have ReSharper installed, ReSharper will very typically notice you doing something like this and suggest to use aggregate. Just go ahead and do that, read the code, and see if you understand it.
And Control-Z, Control-Shift-Z, backwards and forwards over that. Look at where it's putting things. I mean, this is how I went about learning LINQ once I sort of knew the very basics of it, was to write things out longhand and then look at when ReSharper tells me I should be using LINQ and compare what I'd written to how it used that LINQ-wise.
Thank you.
Literally where it would put parameters.
Yep. Okay, so I'm going to go ahead and give everyone something to do, so if you want to participate...
Wolf said,
You what?
Why is aggregate better, though?
It's shorter. Easier to read.
And don't get hung up on the idea of aggregate is something for adding numbers together.
No,
it's not. This is just one example of aggregate is a way of aggregating things in whatever manner. You could be used. I think Segval pointed out a good example earlier on in BuzzNet, which is that you could make a sentence out of words that were passed in.
Yep.
Or you can make words out of strings that are passed in.
And you're not required to pass, like for example, if I wanted to make a min, now remember, some min and max are already in LINQ, but if I wanted to use aggregate to write a min, what I could do is say, or let's do max, equals list my aggregate, 0, AI. Actually, you know what?
Make them do it.
I actually have two things in mind. So,
and min.
Go ahead and implement a max invocation of aggregate, and then go ahead and implement a new method that we're going to be talking about. And hopefully this method should not be difficult to implement. It should be fairly easy, but it'll only be easy if you really do understand the concepts that we've been working on. So what I want people to do is implement concat. Concat should be fairly easy. Given two sequences, let's say 1 and 2, and then 2 and 10, concat should return 1, 2, 2, 10.
You should make them implement it with an overload with a boolean on it as to whether it allows duplicates.
Oh, right. Actually, no. There's another method that does that. Ooh.
Okay.
Actually, yeah, that's a good idea. I don't know if this is going to take forever, but okay. A union.
Huh.
So this is a concat. This is a union. Now, for union, remember hash set of t. Okay, so three things. These two methods, as well as actually figuring out this missing bit in creating a max function in terms of aggregate. All right, so go ahead and hit participate if you want to participate. All right, I'm going to go ahead and pause. And we're back. Okay, so the first thing was implementing a max in terms of aggregate. So what we need to do is a simple ternary will fix this. What we need to do is we need to return if A is, or if I is greater than A, return I, otherwise return A.
And note that quite happily and correctly covers the case where they are equal.
Yep.
Because in that case it wouldn't matter which one you returned.
So let's say I stick a 15 in the middle of this collection and I hit F5, we get 15 as the max.
Have you got anything to say to anyone who did math.max?
Well, there's really no reason to do... Well, I mean, I guess you could.
It rather defeats the point of this, which is to learn how to do it.
Okay, so that was the first bit. Now let's talk about Concat. Concat, who struggled with Concat? Because once you see the implementation of this function, you will probably fully understand it.
Myriad? Are you still referring to the fill in the gap one? For Max, yeah, that won't always be true. I mean, that will. All you're doing there is taking the value of A and putting it in to I, whether it's bigger, smaller, whatever it is.
Yeah, that won't actually do anything. The only reason that would work is because what you're essentially doing... So somebody said, well, what if I did A equals I? I want to point out that this is not what you should ever do. These functions should be pure as possible. This is not a pure function because we do an assignment.
Well, and also, it's not. It doesn't.
Yeah, it doesn't do anything either.
No, I mean, it doesn't. I is always going to be put in. A is always going to be set to the value of I.
Right. So it doesn't have any logic in it.
There's no logic there at all.
But I want to point out, though, that the reason this compiles is because assignment operators in C# evaluate to an expression. So this is an expression. A equals I will set I to A, or A to I, or whichever one.
A to I.
A to I, and then return that value. The only reason that worked is because I happen to have this list was originally 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that if I run this, well, obviously the concat's not going to work, but obviously this is going to return the correct result, 9, because that's the last item inside of it. However, if I stuck a 15 in the middle, it will still return 9. Okay. So
it'll just return the last item.
Yep.
Cool. I don't want you to feel like I was harping on you there, but it was a key, fundamental point of the thing that you understood it, really.
Yeah.
So.
Okay, so concat, or more appropriately, myConcat. What does this function look like? That is it.
Done.
It's really that simple. This is a very important, and again, we're starting to talk about functional programming a lot, because this is a very functional idea of concatenation. We're not actually reaching in and mutating either of these parameters. What we're doing is we're representing the operation. We're abstracting the operation of doing 2 for each loops over something, and then yielding them back to the caller. Hey, James. Okay. Let's just go ahead and talk about union. Unless there's anything else about concat that people are concerned about. To use concat, I can go ahead and show a simple usage. That's it. When I run this code, we will see them concated to each other.
And note that there's no sorting. Can you play it again?
Yeah, actually, I was going to make this a little bit better.
Okay.
There we go.
Yeah, notice that there's no sorting of anything going on. It's literally just going through one by one and adding values. There's no checking either as to anything else.
Yep. No sorting and no duplication detection.
Nelson says this leads us on to union, and this leads us on to one of the most important sort of checks, that, or certainly one of the most common checks you will be doing when you're dealing with enumerables or collections, just generally any grouping of stuff.
Yep. Oh, we did get a question. So when using yield in your concat, it won't return after the first for each loop. Is there a way to force it to return? Or does it know to leave the function? I'm not...
Well, that's kind of built into the way for each works. Once it doesn't have anything else to, the second for each loop will once there isn't anything else to go over in it, it will just
exactly
it'll carry on from line 122, which in this case just involves not doing anything.
So notice how we're continuously looping over this. Execution is, of course, broken apart because of the iterator block. But notice once we reach the end of that, we then jump to line 120, and now we're doing RHS. And once we reach the end of RHS, we leave the function, and we leave the for each loop. This is an example. Hold on. I did list. Okay, we did get an actually good question. This is a valid implementation. Well, this isn't really the reason. There is a reason why this is not a valid implementation. It does seem to work, and it is a logical way to implement it. But the reason it's not a valid implementation is specifically not because that this is invalid code, but because the actual documentation for the concat method specifies that it needs to be deferred.
Why on line 4 is using a list instead of IEnumerable?
Well, what he's doing is he instantiated the list internally, and then looped through both the IEnumerables, adding them to the list, and then returned that list as an IEnumerable.
But doesn't this come back to the... Oh, I suppose, yes, if it's an IEnumerable.
Right.
Doesn't this come back to that problem that you were talking about before, though, where, what if it's an IEnumerable?
Well, he's actually doing the instantiation right there. He's not depending on source or RHS being a list. And that's fine, because source and RHS are not lists, they're IEnumerables. The fact that he has a list here is sort of irrelevant, it's just an implementation detail. Okay. But the reason why this isn't a valid implementation is because the specification, well, there's kind of two reasons. This isn't as fast as the other implementation. That's one of the reasons. It's not as fast because it's not, because we're instantiating a list and we're adding a bunch of items to it. But besides that, it's not deferred. And that's a problem because imagine if source or RHS were infinite sequences. Well, imagine source is a constant sequence, but RHS is an infinite sequence. By doing this right here, we don't give the opportunity to yield back to the caller for the caller to stop the execution of it. Here's an example. If I go ahead and make a static IEnumerable int even numbers, and I make an iterator block to give me all the even numbers. So that's going to look like this. So what we have here is an infinite for loop. Now, if I passed in this iterator block, or the evaluation of this iterator block into this method will hang forever because it'll be forced to run through both of these collections. However, if you implement it like this, you get the opportunity to stop the execution. So I can go ahead and say something like this. let's say I wanted everything in list 1.
Well, you could do while not console read key and wrap that around.
I don't under
That would work, wouldn't it? While not console read key, console key dot escape, and wrap that around what you're doing. You're right.
I
Don't understand what you're not understanding.
I don't understand why I'm not
I
understanding.
really don't, because all you're trying to do is put in a breakpoint.
Well,
The opportunity for the user to stop it.
well,
so.
no. It's not for the user to stop it, for the code to stop it. So, for example, if I wanted to say list 1 myConcat, then pass in even numbers, and then I only wanted the first 40 of them, I can do that.
Oh, okay. So I misunderstood what you were talking about. It sounded like you were saying, because rather than getting one item and then yield returning, at which point you'd have the opportunity to check for user input or anything else like that.
Yeah, true. That's also true.
Sorry, that's where I thought you were going.
And this is a similar thing where, because we're yield returning out, instead of doing a forced loop, we have the opportunity to do .take40. Or, like Gavin suggested, we have the opportunity for putting this in a for each loop and asking the user if they want another item. So, by not having an iterator block, you don't have deferred execution, and there are some problems inherent with that.
I also, just in passing, in your even numbers, could you not do for I equals 0, blank, I plus equals 2, yield return I?
I don't know what you're talking about. I already said that.
Okay, just checking. Must be lag.
Yeah. Okay. So, yeah. Let's go ahead and now talk about union. So union has a very similar signature, but has a very important aspect to it that makes it different than concat. And that is that union will only return items that are unique. And so I remember a conversation we had in C# 102 when we talked about the HashSet class, and people were like, why would you ever use the HashSet class? That seems like a stupid type. Well, because of stuff like this.
Do you want to, I know you probably don't want to, but would you also write another version that doesn't use the hash set? Because that's more likely to be what people have actually
I wouldn't know even how to
anything.
do that. That would actually be very unperformant.
Well, see, this is what I was talking about earlier, because I was going to do if not contains.
Oh, you wouldn't be able to do, well, you could do contains, because contains is a LINQ method.
Exactly.
But that would still be not performant, because the hash set is actually very, very quick in determining uniqueness of things. Whereas doing that would require, that would be O(n) squared complexity, I think, because for every iteration of the loop, you would have to do another iteration of another loop, with the maximum worst case of being bad. Okay, so now if we go ahead and do my union instead of my concat, what we'll get back is a list of unique values. Okay, so how is everybody feeling about this implementation of my union? Remember that the HashSet.Add will return false if the item's already in existence. That's the only thing that you really need to know. Well, the myUnion,
it's a union. A union is a list of the items. It's exactly the same as a concatenation, except that it only has unique values in it. So if a value already exists, it won't get added again.
Yep. Or to slightly rephrase that, it's not we're not adding anything to anything, but it won't get yielded back. I mean, that accomplishes the same thing as far as English is concerned.
Yeah, yeah.
With that. Well, it's doing that by looping through both of these enumerables and determining by doing HashSet.Add if those items already existed. Because HashSet.Add does two things. It adds the item to the hash set, but if the item already exists in the hash set, it returns false. If the item doesn't already exist in the hash set, it returns true. So we're saying if the item already exists, then yield it. Or if the item doesn't exist yet, then yield it. Otherwise, add it to the list or to the set. That's more appropriate to call this a set because that's exactly what it is.
Segful did bring up something ages ago while we were while the recording was stopped, which was what happens if you want to do multiple concatenations or unions, i.e. passing in
You do something like
left-hand side, a middle, and a right-hand side.
You just do it over and over and over again. Like that. Okay, so let's go ahead and...
Sorry, but he did just ask the question, which is, but isn't this inefficient requiring many hash sets?
Well, yes. It does require many hash sets. I will say, though, I don't often chain unions or concatenations very many times. Typically, when I use, in the wild, when I use unions or concatenations, they're concatenating or unioning two things together. It's not very common that I'll chain them. And in the case that I do chain them, it's not the end of the world, really. And it's just, if you wanted to, again, it's the features of programming. This code is significantly cleaner, more readable, and more maintainable than if I had used just one hash set and made my own implementation for a specific case. However, if you absolutely need those nanoseconds of performance, then you will trade the readability and maintainability of the code for additional performance. The resulting code will be significantly larger, significantly more difficult to maintain, and significantly harder to read, but it will perform faster. I do want to also point out something interesting about how iterator blocks work. The hash set that is instantiated on this last myUnion is tied as a field to the combined object. In fact, if IntelliSense isn't smart enough, I should be able to look at it. No, it's sadly, it's abstracting away the fact that there is actually a hash set field on this object. That means that while this IEnumerable is in scope, the hash set will not be garbage collected. And that's about that. Okay, so given that we know now, so does everybody want another challenge? Is everybody up for some coding? Because we're going to be looking at two other very important implementations, or very important methods. And I also want to point out something really quickly. You'll notice that the union method, the real union method, does take in an IEqualityComparer as one of the overloads. I want to make that very clear to people who might be looking through the real signatures and notice this IEqualityComparer thing. But what that means is the IEqualityComparer is simply the way in which it determines equality. If I wanted to implement my union that accepted an IEqualityComparer, it would look like this.
Joy, at last.
At last what?
I want to see you implementing equality members.
No.
Without resharper.
Nope.
And see if you can remember how to do it.
I'm not going to do that. I'm just going to use the defaults. Okay, so in... what are you complaining about? Oh, derp. There we go. Okay, so what we have here is we're now passing in the IEqualityComparer. What an IEqualityComparer is it's basically just something that can compare the equality of two things. So, for example, if
basically, I mean, yeah, if you're dealing with numbers, then equality is, or everyone knows what equality is. But if you're dealing with strings, for instance?
Yeah, and I'll go ahead and show an example of that. But because that's actually the biggest use for equality comparers, at least in daily use. But notice how I pass in the equality comparer into my hash set. This is actually how LINQ really implements these members. It passes in the compare to the hash set or to whatever mechanism it uses. I've seen John Skeet's code on my on his implementation of union, but I don't know. I've never actually decompiled the true source of this, but I'm sure it uses a hash set or something similar. Regardless, it uses the compare to determine if two things are equal, which you might be like, well, why should that matter? Well, let's say I wanted to get the union of these two lists, but I wanted the comparison to be case insensitive. You'll notice that by default, and I'm going to go ahead and overload my union. This is actually how it works in .NET, where there's an overload that doesn't take in an iEquality compare. It just passes in the default equality compare. Okay, so blah 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 blah.
Stuff and things.
Sorry, Jess. That's what I was missing. Okay, so let's say that we wanted to get the union of these two things, but we want it to be case insensitive. You'll notice that by default, if I did for each bar item in list1 dot my union list2, you'll notice that by default we'll get hello world, and then we'll get all caps hello and stuff, and we don't want that. We don't want two strings to be considered. We want two strings to be considered equal, even if they differ by case. So what we can do now, because we have a overload that takes in an iEquality compare and passes it into the hash set, I can now pass in string compare dot current culture ignore case. And now when I hit F5, notice how the behavior has changed significantly.
And that's a big thing, that ignoring case, because remember, as far as the computer's concerned, a capital A is, what is it, 50?
Is it 49? I don't remember.
Is it 40? No, 59, I think, or something like that. It's about that. But anyway, it's a specific
number,
index of how to display it, and therefore it's not the same thing as a lowercase, as a or vice versa, stuff and words.
Right. A computer sees them as numbers, and they're different numbers, and if they're different numbers, they're not equal. But by doing the iEquality compare is something that's very common in .NET and something I hope people get used to doing. But you can pass in equality compares into things like dictionaries or hash sets. And the main use for them is for determining the case of strings. Of course, there's nothing stopping you from implementing your own equality compares. Keep in mind, though, that the default equality compare will defer to your object's implementation of equals. If there is an overload to that, and if both items aren't null, that's trying to compare. Yeah, iEqualityComparer has one method on it. If you look at it, it's just equals, which is funny because equals is forced. So this is the overload of equals that's forced to exist because obviously iEqualityComparer, well, anything that implements iEqualityComparer has to inherit from object, and object has the equals method on it. But if we look at the second overload, that's the only method that iEqualityComparer is required to implement, which is the equals tx ty. So I hope people learn something new about string. Is anything about the equality comparers or string comparers difficult or Are people not following? Or because this is...
I think the concept's very straightforward. You're basically just saying these things will be equal in certain circumstances, and I will define what those circumstances are.
Right.
But obviously common cases, like dealing with strings and upper and lower case and different cultures, i.e. decimalization, using full stops or commas and things like that, those are common cases, and so they're implemented in the language for you already. It only gets complicated really when you start defining your own, and that's just because the syntax is just ugh.
We did get a question, why is the net implementation of union second part is IEqualityComparer in T? Why in T? And what he's referring to is this. The in and out modifiers of generic parameters is not something we're going to go into detail on today, but what it is it's a feature that was added in .NET 4 called Covariance and Contravariance. And it actually, I read this really interesting article that equated it to category theory, which category theory is an interesting branch of mathematics that it is so ridiculously abstract that even mathematics make fun of it for its abstractness. But it's very commonly used in programming and generics and stuff like that. And covariance and contravariance are just ways in which different types can be passed in to fill this type parameter. Depending on if they're a super or subclass of a type. And I know that sounds confusing, which is why we're not talking about it today. But that's what the out and in is.
Read out what the tooltip says. The type of object you compare. It's contravariant. That is, you can either use the type you specified or any type that is less derived. For more information, please go and read this huge article.
I didn't notice that, but yeah. So yeah, and if you want to read about that, it's a very esoteric.
Even the people who were writing the documentation couldn't be bothered to write it in there.
Yeah, because it gets really, really abstract, and it's a really obscure feature. I'm not sure of method on line 124 or 124. Yeah, this is an overload of union that simply it invokes this implementation of union, but it provides a default parameter. And the default parameter it provides is the default equality comparer of T. And that's it.
See, this is something that, and I'm intrigued as to whether it's just your preference or whether there's performance reasons, or why is that preferable to setting it as a default?
I go back and forth on default parameters all the time. I think we've had discussions in class about the reasons why. In fact, if you turn on the Microsoft FXComp, I can't remember what the name of it used to be called, FXComp, for going through your code and seeing if you have any problems. If you have a default parameter on a public member, Microsoft's own tool will tell you that's bad code design. For a variety of reasons, namely breaking binary compatibility, as well as not being compatible with other languages. So it's a feature that I typically don't use. And second of all, what I would have to do to use this as a default parameter is I'd have to set this to null, and then I would have to check for null within the method. You know what I mean? I can't just set compare to equalityComparer.default.
Oh, right, okay. Why not? You just can't.
You just can't. Okay. What does it default to? When and how would you use it? Well, here's an example of when you would override the equality comparer. Notice how I have two lists of strings, and I'm passing in a current culture ignore case, which is a string comparer. And a string comparer is a class that implements IEqualityComparer. So if I want the comparison to ignore strings or ignore cases, what I can do is I can pass this in optionally. Otherwise, the default equality comparer is used. And the default equality comparer is what you would typically get by using the equals equals, the equality operator. So like, for example, for reference types, the default equality comparer will check to see if the references are equal. For value types, it'll check to see if other stuff. Well, it's a case that you want to override the behavior of equality. That's the only thing. The only reason we're using this here is because in the case of strings, there just happens to be a good example that I use quite frequently. I've never implemented my own equality comparer ever.
Say you had a car comparer that decided whether two cars were equal. It would need to know about things like whether or not they've both got 5 doors or whether one of them's got 3 doors. It would need to know whether the colour's the same, whether they're the same make. What a surprise, come up with a card example. But it's a good example. You know, if you're comparing playing cards, you need to know, well, whether they're the same suit and whether they have the same value. Those two things being equal. Specify that's what equality means when you're dealing with playing cards.
Right.
Equality when you're dealing with numbers, as we said, is just whether it's the same number. But also, you know, you get, yeah.
Yeah, and
I don't know how else to put it.
typically for implementing stuff like that, you would override the equals method, because the default equality operator will check to see if you have an equals method. Well, it'll invoke the equals method that you put on your own type. So you would generally not implement an IEqualityComparer for those cases, but you, like for example, bringing back the car example, let's say there are 2 different ways that you want to compare cars. Let's say that in this one situation you determine that 2 cars are equal because they have the same amount of doors, but in another situation you determine that 2 cars are equal because they're the same color. Now, while you certainly could, at that point you can't override the equals method because equality is different depending on context. So you abstract the concept of equality out into 2 separate classes. One car equality comparer that checks to see if the doors are the same, and another car equality comparer that checks to see if the color is the same. So that's the same thing with strings. Sometimes we want a case-sensitive string comparison. Sometimes we want a case-insensitive string comparison. So that's why it's important to have the concept of an IEqualityComparer, because you can change it depending on what exactly you want. So does that make sense? Okay, so we're getting...
Default equality comparer is no different to any other sort of default of any other thing. It's a default. It's something that it defaults to. Yeah. Anyway, yeah, we should probably...
Yeah, I'm going to go ahead and give people stuff to do. There are 2 methods that are really nice to use for a variety of things. We have accept. So, for example, this case would turn into 1, because it would be 1 accept, or a list 1 except the items that are in list 2. And then we have intersect.
Would that just be 2, or would it be... Yeah, it would.
Intersect does the opposite. It'll return things that are present in both lists. So, for example, it would just be 2. These are very important methods to understand. And again, remember HashSet.
Is there an exclusion? Oh, no, sorry, I'm being very... Not an exclusion. There's one more possibility, and I can't think what it's called. The one that gives you back the items that are in one list, but not both lists.
Wouldn't that be a union?
No. Never mind. No, because this is the thing, K73, except doesn't have 10 in it. It means return or deal with the things that are from the first IEnumerable that aren't in the second one. Not the unique one, so the ones that are in one or the other. That's kind of what I was getting at. Is there not one that returns the ones that are only in one of the lists, but not both, that would give you back 1 and 10?
Now I'm My brain isn't working.
Well, you can have a look for that on the while people are coding.
Okay, so go ahead and implement these guys, and we're going to go ahead and buff. Okay, so except. I vaguely remember a very elegant implementation of this method, but I'm probably going to botch it a little bit, just trying to implement this method out of memory. Not memory, but out of what it does, so bear with me. What we need to do is we need to return everything that is in the source list that is not in the other list. So what we could do is we can go ahead and create a blacklist. Now you'll notice the HashSet has a constructor that takes in an IEnumerable of t, which is great because now I can say blacklist equals HashSet of RHS. So now I have a blacklist, and now I can go ahead and say, you know, for each var item in that, if blacklist add item yield return item. So that's going to go ahead and I realize that some people will have implemented this in terms of like maybe they looped over RHS manually and added it all into the hash set. What I wanted to show right here though really quickly was there is an overload. Almost every single collection type has an overload that takes in this.
Can I ask you about what my sort of vague, I didn't actually code this out, so I don't know whether it works or not. This is why I'm just checking, but could you not essentially do the same as you're doing with the union, except, like for instance, line 134, could you not make that if not set.add? Or am I...
No, because that would also include items out of the other list. We don't want to include items out of the other list. We want to use the other list as a way to blacklist items.
Yeah. I was kind of looking at it going, all right, my first thought was, oh, you could do that. And then I looked at it, the more longer I looked at it, the more I thought, no, that's going to cause some sort of problem.
Why don't you accept duplicates in the first IEnumerable? Good question. That was an oversight on my part. I probably should have specified that the documentation of accept does indeed say that if there are duplicates in the source enumerable, they are not included. Okay, so let's go ahead and implement Intersect. So Intersect is basically the same, I mean, just the opposite, really. And it is a very interesting implementation. But what we can go ahead and do is do this. So the first thing we're going to do is, instead of getting a blacklist, we're going to get a list of potential items. Or we're going to get a hash set of things that exist in the RHS parameter. So we can say items that exist equals new hash set of t passing in RHS. Now we can say for each var item in that, we can say if items that exist dot remove. Now remember, remove will return true if the item was actually successfully removed, or false if the item didn't exist. So we can say if items that exist dot remove item, then we now know that that item has existed, whoops, in both the collections. So how's everybody feeling about Intersect? Well, except for my lack of proper naming.
And the fact that you can't spell intersect.
Oh, we overlooked that anyway.
You're happy? Can he spell amount? Yeah, Jason.
Shut
shut it. That was Logan's fault, man.
That was entirely Logan's fault. No, I
It was.
agree.
And but the funny thing about it, while it was his fault, he used some sort of wicked voodoo on me because
Isn't it? He brainwashed
he did. He convinced me that that was correct, and my inner child was screaming that that was so wrong. But hey, man, it's Logan. He had to be right. I'm just saying.
Alrighty, so let's go ahead and look at a few more implementations of LINQ stuff. So one of the LINQ methods that I use quite frequently is the Two Dictionary LINQ method. And again, I'm kind of tempted to see if people... Actually, who's up for some more coding?
Yeah, well,
Because we've done a lot of coding today, but this one's going to be a little bit of a challenge for people, I think.
Ooh, challenge.
So, yeah, it might be some fun.
I say do it.
Okay, so go ahead and implement this method. It's going to be public dictionary t-key t-value two dictionary, or my two dictionary, or whatever. It takes in an IEnumerable, or sorry, I'm missing a generic parameter, t-source t-key t-value. It takes in an IEnumerable of t-source. It also takes in a func that maps t-source to t-key, called key projection, and it takes in a func that takes in a t-source and returns a t-value called value projection.
am I going mad, or are you sure that's integers? Is that public dictionary?
Public static dictionary.
Well, not even that. I was looking more at the you've got 3 parameters in the dictionary.
Wow, how did I fail that badly?
Well, see, you failed so badly that I wasn't even sure. I thought I was misunderstanding dictionaries. I was like, that must be right. It's like Logan and amount again. I was literally going, oh, well, Nelson typed it. It must be right.
See, now you know the feeling.
Okay, I want to point out that this isn't the only overload of Two Dictionary. So if we actually go ahead and look at the overloads of Two Dictionary, there's quite a few of them. Well, 4. But, and including one that takes an IEqualityComparer. Don't worry about the IEqualityComparer. Actually, no. Worry about the IEqualityComparer. You know what?
Only if you're going to code it out, proper equality members, and explain them without using resharper.
Never. Okay, so go ahead and implement this method. I'm going to go ahead and hit reset on everybody. Hey everyone, sorry about this, but my internet connection died. So yeah, we'll be resuming next week. And goodbye everyone.